China's Fujian aircraft carrier, a towering symbol of naval ambition or a risky gamble on the high seas? Boasting advanced catapults and a modern design, it aims to rival America's Gerald R. Ford. Yet, with conventional power, limited logistics, and unproven tech, is it a regional titan or a potential maritime disaster? Join us as we dive into the Fujian's strengths, flaws, and what it means for global naval power. China's latest aircraft carrier, the Fujian Type 003, is hailed as a symbol of naval modernization and has been touted by Chinese state media as a rival to the U.S. Gerald R. Ford-class aircraft carrier. However, despite its impressive appearance and massive size, the Fujian suffers from significant performance shortcomings compared to the Ford class, potentially risking a maritime disaster. In contrast to the mature technology and global power projection capabilities of U.S. carriers, the Fujian's limitations expose the technological and experiential gaps of the Chinese Navy. Background and symbolic significance of the Fujian. The Fujian is named after China's southeastern coastal province, a region significant both as the political birthplace of Chinese President Xi Jinping and for its strategic position across the Taiwan Strait from Taiwan. Once commissioned, the Fujian will significantly enhance the combat capabilities of China's East Sea Fleet, which is responsible for overseeing the Taiwan Strait. As China's first indigenously designed catapult-equipped aircraft carrier, the Fujian marks a major leap from the ski-jump takeoff systems of its predecessors, the Liaoning and Shandong, to a catapult-assisted takeoff but arrested recovery, catabar system. Construction of the Fujian began in March 2015 at the renowned Jiangnan shipyard. The carrier was launched in June 2022, began its first sea trials on May 1, 2024, and is expected to enter service this year. The Fujian is currently China's largest surface warship, embodying Communist China's ambition to become a naval superpower. Military modernization is a key component of President Xi Jinping's so-called Chinese dream. To this end, China's defense spending has grown at a compound annual growth rate, CAGR, of 7.5% since 2019, reaching $230.3 billion in 2023 and projected to hit $323.7 billion by 2028. Naval defense spending has seen particularly rapid growth. For instance, the budget for the Type 052D destroyer is expected to grow by 17.09% from 2023 to 2028, far surpassing that of the U.S. Arleigh Burke-class destroyers. Between 2024 and 2028, China's Ministry of Defense plans to spend $1.4 trillion on producing military hardware and fully modernizing the Chinese military. These massive investments have strongly supported the comprehensive research, development, and technological upgrades of large surface vessels, including the Fujian. However, the carrier's actual performance still falls far short of the ambitious requirements of China's expansive plans. Compared to China's two earlier ski-jump carriers, the Fujian represents significant progress in design and technology, even surpassing the capabilities of some existing carriers, such as France's Charles de Gaulle or the UK's Queen Elizabeth. The Fujian is China's first carrier equipped with an electromagnetic aircraft launch system, EMALS, featuring 3 catapults, which is far more efficient than the ski-jump systems of the Liaoning and Shandong. The Fujian can carry approximately 40 to 60 aircraft, including the J-15T, the J-35 stealth fighter, and the KJ-600 airborne early warning aircraft. Its flight deck adheres to Western standards, incorporating an angled landing area and a side-mounted island superstructure. However, unlike its U.S. counterparts, the Fujian is equipped with only 2 elevators, one forward of the island and one aft of the starboard island. This limited number of elevators suggests that, compared to U.S. carriers, which typically have 3 elevators for more efficient aircraft handling, the Fujian has a smaller aircraft capacity. The Fujian's propulsion system relies on conventional power, steam turbines, while its diesel generator integrated electric propulsion, IEP system, supports high-energy systems like the EMALS. On May 1, 2024, the Fujian began its first sea trials, lasting 8 days, longer than the 5-day trials of the Liaoning and Shandong, indicating a more extensive testing scope. Its conventional propulsion system performed well, with minimal wake and agile maneuverability, and power distribution initially validated the reliability of the EMALS. This positions the Fujian as a standout among the 9 countries with aircraft carriers: France, India, Italy, Japan, Spain, Thailand, Turkey, the UK, and the US. However, the U.S. Gerald R. Ford CVN-78, the pinnacle of nuclear-powered carriers, represents a century of carrier expertise. Compared to the Ford, the Fujian's critical flaws are glaring. Propulsion system. The Fujian employs a conventional propulsion system combining steam turbines and diesel generators with an IEP system to support high-energy equipment like the EMALs. Compared to nuclear-powered carriers, conventional carriers are limited by the need for regular fuel resupply, which depends on the carrier's speed, operational intensity, mission type, cruising or high-intensity combat, and fuel reserves. Based on the operational experience of similar conventional carriers, such as the U.S. Kitty Hawk class, with a displacement of approximately 83,000 tons, close to the Fujian's 85,000 tons, a conventional carrier cruising at moderate speeds, 18 to 20 knots, can typically operate for 5 to 10 days on a single fuel load. Military experts estimate that the Fujian may need to carry around 12,000 tons of fuel and require resupply every few days to a week during combat operations, depending on mission intensity. In high-intensity operations, frequent aircraft launches, high-frequency EMALs use, or high-speed sailing, fuel consumption could increase significantly, reducing endurance to 3 to 5 days. In contrast, the nuclear-powered Ford requires only aviation fuel, food, and munitions resupply, with an operational endurance spanning decades. Logistics and replenishment. Underway replenishment is typically conducted by large comprehensive replenishment ships, such as China's Type 901 replenishment ship, which connects fuel lines to the carrier during parallel sailing to transfer fuel. These ships can also provide munitions, food, and other supplies known as comprehensive replenishment. The Type 901 replenishment ship Chiganhu is a dedicated fast replenishment vessel designed to support carrier strike groups. It can carry tens of thousands of tons of munitions, food, and various fuels, with capabilities for lateral, longitudinal, vertical, and nighttime replenishment, extending a carrier strike group's endurance by nearly 10,000 nautical miles. According to Chinese state media, the Type 901, designed as a 50,000-ton class vessel, can carry over 20,000 tons of various supplies, munitions, and fuel, with a top speed exceeding 25 knots. Its propulsion system is estimated to produce around 200,000 horsepower, comparable to that of the Liaoning. China has built 4 such large replenishment ships. A critical detail is the time required for fuel replenishment. Based on historical data from U.S. conventional carriers like the Kitty Hawk class, a single underway fuel replenishment typically takes 2 to 6 hours, depending on the volume and equipment efficiency. China's Type 901, designed to support carrier strike groups, has efficient fuel transfer capabilities, theoretically keeping replenishment times within 3 to 5 hours. However, due to the high energy demands of the Fujian's IEP system and EMALs, replenishment volumes may be larger, potentially extending the process. If the Fujian returns to port for resupply, such as at the Jiangnan shipyard in Shanghai or a naval base, the process is typically longer, taking 12 to 24 hours, including docking, resupply, and departure. Port resupply allows for simultaneous large-scale maintenance and supply loading but renders the carrier temporarily inoperable, making it a fixed target. Lack of replenishment bases. This is another major weakness for the Chinese Navy. As mentioned, the Ford can continue operating as long as it has food, fuel, and munitions, thanks to the U.S. Navy's extensive underway replenishment network. In contrast, the Chinese Navy, plan, lacks a comparable system, and the Fujian must rely on periodic port visits for refueling and resupply. This dependency could be a fatal flaw, particularly in prolonged conflict scenarios. Moreover, China faces geopolitical isolation with limited access to strategic ports globally, exacerbated by recent U.S. actions, such as expelling China from the Panama Canal under the Trump administration. This isolation largely confines the Fujian to a regional role, operating near China's coast or its artificial islands in the South China Sea. In long-range conflicts or global warfare scenarios, this severely limits its effectiveness. Meanwhile, the Ford, supported by the U.S. Navy's global replenishment network, supply-class TAOE ships with a 48,800-ton displacement and 18,000, 20,000-ton capacity, can resupply fuel, food, and munitions almost anywhere, backed by robust U.S. and allied logistics. Stability. The Ford measures 1,092 feet in length and 255 feet in width, with a full load displacement of 100,000 tons. The Fujian, while comparable in size at 1,036 feet long and 249 feet wide, has a displacement of only 80,000 to 85,000 tons. The Ford's additional 20,000 tons result in a deeper draft and a lower center of gravity, enhancing stability. A lower center of gravity allows for more aggressive maneuvers with greater control. This improved stability also reduces roll and pitch, providing a more stable platform for flight operations and better performance in rough seas. Catapults and elevators. The Ford is equipped with 4 EMALS catapults and 3 electromagnetic elevators, enabling 20-30 aircraft sorties per hour, with a peak capacity of 25-30 sorties. The Fujian has 3 EMALS catapults and 2 hydraulic elevators, supporting 15-20 sorties per hour, with a peak of about 20 sorties. The Ford's additional catapult and elevator significantly enhance deck efficiency. The Fujian's hydraulic elevators limit aircraft scheduling, and power distribution may constrain sustained EMALS operations. Armament. The Ford is equipped with a robust array of self-defense systems designed to counter various threats. Close-in defense, 2 Sea Sparrow launchers, and 2 rolling airframe missile RAM launchers provide strong protection against incoming missiles. These are supplemented by 3 Istral 20mm close-in weapon systems, CIWS, capable of firing thousands of rounds per minute to neutralize threats. Surface threats. The Ford carries 4 25mm Bushmaster chain guns and 4 50 caliber machine guns to engage small boats and attack craft. Electronic warfare. The Ford's advanced electronic warfare capabilities, particularly the SLQ-32V6 system, integrate active and passive measures to detect, track, and neutralize threats using sophisticated radar and electromagnetic technologies. Underwater threats. The Ford is equipped with decoy launchers to mislead incoming missiles and a Nixie torpedo decoy system to confuse and divert torpedo attacks, providing additional protection against subsurface threats. In contrast, the Fujian's self-defense capabilities fall short in several areas. To compete with the Ford's Sea Sparrow and RAM systems, the Fujian reportedly carries 3 18-cell missile launchers, likely equipped with HQ-10 surface-to-air missiles. Compared to the Ford's robust systems, these missiles have less proven combat performance and shorter ranges, 5.6 miles against subsonic targets and 3.7 miles against supersonic targets. The Fujian may also carry 2 RBU-6000 rocket launchers designed to attack submarines with contact-fused munitions. By modern standards, this system is considered somewhat outdated and unsuitable for precision strikes. In short, the Fujian's armament is functional but less refined and sophisticated. The Ford's air wing can include up to 40 FA-18EF Super Hornets, forming the core of its fighter force for air superiority and strike missions. It also carries up to 7 EA-18G Growlers, specialized in electronic warfare and suppressing enemy air defenses, ensuring dominance in electronic and cyber warfare. Additionally, the Ford supports 12 MER-60R Romeo helicopters for anti-submarine warfare and 8 MH-60 Seahawk helicopters for versatile missions, from search and rescue to anti-surface warfare. The Ford's weapon systems form a fully operational, combat-proven platform capable of handling diverse aircraft types, carrying heavier payloads, and requiring less maintenance. With 4 catapults, one more than the Fujian, the Ford enjoys clear advantages, as previously discussed. Radar and electronic system. Ford is equipped with a dual-band radar system capable of simultaneously tracking and engaging multiple targets with rapid response and simplified maintenance. The Fujian relies on traditional Doppler radar systems, which are less capable of real-time threat processing, a clear sign of technological inferiority. This means the Ford far surpasses the Fujian in situational awareness and reaction speed during naval combat, representing another critical weakness for China's carrier in future conflicts. The Fujian aircraft carrier is a symbol of China's naval ambitions, but its technical shortcomings, lack of experience, and logistical limitations place it far below the Ford. Calling it a naval disaster may be an exaggeration, but it is still far from achieving China's lofty goal of rivaling the U.S. In the Indo-Pacific region, specifically in China's coastal waters, the Fujian's deterrence is undeniable. However, to challenge global naval supremacy, China must bridge significant technological and strategic gaps. Do you believe the Fujian is a successful regional strategic platform or a multi-billion-dollar extravagant waste? Share your thoughts and suggestions in the comments below. Thanks for you watching. We'll see you next time.